Welcome to Landwards, the podcast for the land-based engineering community, brought to you by the Institution of Agricultural Engineers.
I'm joined by Professor Dan Ridley Ellis from Napier University, Edinburgh University?
Edinburgh Napier University.
Edinburgh Napier University, the first of many errors in this interview, I'm really sorry. And Dan, you've spoken at FEG Symposium today really about the purposes and the future purposes and use of wood. I wonder whether, and I hate the analogy of Twitter / X, but we can't reduce your 30-minute presentation into 150 characters. But just give me a brief flavour of challenges, opportunities, where are we going with timber use?
Well, I basically came here today to talk about species diversification. I mean, we've done a lot with our main commercial species, Sitka spruce, larch, Douglas fir, those. But there are a lot of reasons why we need to be thinking about other species for the good of the industry in the future. But there are lots of different choices that we have and not much time to make those choices. So I just wanted to talk about what we know about different species, what criteria we're using to input into that species choice decision that are informed from the point of view of wood properties and wood products. And there are a lot of barriers to the way that we use wood that are actually coming from the way that people think about it. Because we have
it's our perceptions that timber is good for that, rather than actually focusing on the technical abilities.
Or more problematically, a lot of people just ruling it out and saying, well, this timber is no good because, and often the because is not real.
You gave a really interesting analogy about French and English oak, which, as you said, was it's the same tree, it's just been grown in a different climate.
Well, that's the other aspect of this. So species is obviously really important from a forestry point of view, but for many users of timber, it's not actually important what the tree species was, and most users might not know exactly what they're working with. The things that matter are the properties, the characteristics of the wood. And the properties and the characteristics of the wood are influenced both by the species and by the growth conditions. Because trees, they're very selfish, they grow wood for their own reasons.
Yeah,
I am pretty sure they don't think about us at all.
No, and the concept of gardening, the concept of agriculture is create the right environment and it will grow, it will produce.
Yes, and forestry is a slow process, so if we compare it to agriculture and the speed in which we can change a crop in agriculture,
or accelerate breeding.
Yeah, exactly. So we're kind of like in the Stone Age if you do.
Yeah, because of the cycles. And you gave a great comment, which was that the timber we need in 2050 is already in the ground. And when you start to think about that, it puts a bit more of an imperative on the what the hell are we going to do?
Well, yeah, I'm commonly talking to foresters, and one of the messages that I try to say that, well, you foresters, you growers, are the people with the biggest influence on the wood properties of everyone. And the other thing is that, the future resource that we have for this 2050 and beyond, we already know what it is. The foresters are working in the future. We already made those decisions. And we're already starting to feel some of the consequences of mistakes, decisions that we made based on limited information and the fact that the world has changed. And then, based on that, we should probably think, well, what mistakes will we be making in the future? What will future generations be cursing us for? Maybe we should be planning ahead. But there's quite a lot of just assumption that if we plant a certain species, that will automatically produce quality timber because someone has heard that this timber produces, or this species produces quality timber. But it doesn't work like that. And even if you did produce quality timber, doesn't mean that a market will automatically grow around it.
And you discussed the fact that potentially, say, 500 different species could grow timber could grow in the UK, and maybe there's 100 at the top end of that which are worth a look. And then you also made the point about how many samples of a given species of timber you would analyse in order to get some meaningful data, and you still put some great, this is for listeners obviously, some great graphs up showing a massive range of technical performance within one species. So, the old sort of shooting a shotgun at the graph chart, and you go, well, look, it's somewhere in the middle, but that doesn't mean that, 60% of those samples would be nowhere near that average.
Mm-hmm.
So those are technical challenges, again, around our assumptions.
Yes, and some of the data that we have is very small sample sizes. So if you're only talking about 10 pieces, 20 pieces, that's almost a random number.
Yeah, it's not necessarily enough to hang your hat on and build an industry around, is it?
No, and also the issue is that if we're taking timber from one of these potential future species, it's probably coming from an experiment or a forest garden or something.
Yeah.
It's not going to be typical of what we would be doing with it if we were planting it at scale for production.
If you look at the breeding which is behind the latest generation of Sitka, or a commercial softwood or a commercial hardwood, you've had generations to get to that point. So there are challenges with it's a new species in terms of commercial growing. There are challenges, what's its provenance, what's the history, why have we not grown it? Is it some kind of evolutionary timber appendix?
Yes,
you can have that phrase because I've just made it up. I don't know what it means. But, it just happens to be there.
Yes, but also bear in mind that we don't actually need to have perfect knowledge. That's the good thing about it.
We just need some.
We just need some,
better.
right? There's different levels of knowledge that we need. And if you're going to be building a building with timber, you need to have a good certainty that this isn't going to fall down because that's going to ruin someone's day. But if you're just making decisions or comparing things, really you just need a ballpark or a sniff test. And that's when having...
And the issue at the moment is we haven't even got the sniff test.
Exactly.
So some data is better than no data.
Or people are basing it on the reputation of something which might not be deserved.
Yeah.
So if we have some data that says this is more or less in this area, this level of properties, it's not going to be vastly different from that if we were able to test much more of it. So it's just going to give us a rough idea of where it will be, and in the short term we're looking for stuff basically that's a lot like Sitka.
Yeah.
And Sitka's perfectly suitable for a lot of things that we want to use timber for. And if we can find something that's almost as good as Sitka and its properties...
And can cope with climate changing.
And can cope with climate change, but also would be processed and sold and maybe mixed in with the spruce resource, then that would be ideal. And as I said at the beginning, the user doesn't really
need to worry about it. Because you're right, technical performance is technical performance. It doesn't matter which species it's come from. It's more the fact that it can work in an existing system.
Exactly. And when we talk about homegrown spruce, people say it's Sitka. Well, 10% of it's Norway spruce.
Yeah.
So we're already we're assuming.
Well,
that
we've
it's
used
one
the word
thing.
Spruce, though, haven't we? So to a timber ignoramus like myself, it's spruce. But,
you wouldn't be able to tell spruce apart from.
No. That's right. If you brought a few samples and I go, well, that's clearly wood, it's got a grain.
Yes.
You've just hit me with it and it hurts.
if it's similar in colour.
Yeah, that's right. If it looks like a duck, etc. Well, look, Dan, I really appreciate your time today, and particularly because this is being recorded right at the end of the day, and you could have been in the car heading north or several minutes ago at least. So thanks ever so much.
No, thank you. Thank you.
I'm now joined by Anna Quinalo, who is an engineer for Arabs, and she's been talking about SUDS, which for the uninitiated, myself included, is sustainable drainage systems. So Anna, as a punter sitting at the Forestry Engineering Group Symposium, I'm sitting here going, what does this mean? So you've really been part of a two-part presentation where you framed what the law does and how it does it. Quickly, tell us, and it's impossible to condense, a 30-minute presentation into 3 minutes, but what does SUDS mean and how do you go about it?
Yeah, so thanks. So I work in the water team at Arup as a senior consultant, and I work on a range of water projects. SUDS are those sustainable drainage systems, and what I talked about today is that we've got guidance and regulation that's designed around working in an urban environment that we're trying to apply across to these rural contexts where we're trying to put new infrastructure in. So it can be a real challenge trying to meet those standards that are set out for a completely different environment. But there's also really good opportunity and solutions coming up in terms of integrated water management and funding for those sorts of things that is going to help us use our land better and manage our land better to reduce flood risk to our communities. And it's just about how we all work together to do that and how different disciplines come together and different expertise can come together to actually deliver those solutions on the ground.
And I'm guessing within forestry, the context is we're putting roads in to extract timber. We're doing things with land rather than it just being a stand of trees because it's a process of growing trees, which then comes within in the coverage of SUDS. and a set of legislation which may fundamentally have been designed predominantly for an urban environment is being applied across the board to the entire landholding of the UK, which is where forestry comes in. So it's new for forestry, which is why it's on the programme for this symposium. So part of my remit as editor of the Institution's magazine is to encourage people about the viability of a career in the land-based industry. Now, I'm quite sure you look at me and say, but I'm not an agricultural engineer, Andy. But tell us about your day job and how it interfaces with land, water and the fundamentals of agriculture.
Yeah, so it's a really good question, and to be honest, my day job's quite complex and interfaces in lots of ways with these different areas, but it's something we're working on increasingly and very much so for agricultural engineers, particularly looking at the way that we manage those land uses, looking at the way we manage space is a growing discipline. There's more and more funding coming into it and more thinking about, how do we manage this land and how do we pick up the soil and the water, how are we looking at. So part of what I do is looking at how can we manage soils differently, how can we channel water differently so that it moves across the landscape in a better way. And actually, I think agricultural engineering is one of those things that people almost forget about when you're pulling together those interdisciplinary pictures. But to me, it sits right in the middle of all of our management of land and water going
And I think there's a big mistake that people assume that agricultural engineering is about things with wheels on and tractors, rather than the fundamentals of the use of soils, whether that crop happens to be a field of wheat or a field of trees, and the things you have to do to that field of trees, in this case to harvest them. And traditionally, landscape scale planting in the UK has been on difficult land which you wouldn't otherwise use for anything else. By dint of that means it's steep, it's wet, it's rocky, it's challenging, which again has direct issues with water flow.
Exactly, and that's the sort of complex work that we get involved with as engineers is thinking about how you deal with these complex challenges. How do you move a vehicle across a really steep slope? How do you access a track through a really complex site? If you've got a really steep hillside and we're expecting rainfall to keep increasing, what do you do with all that water you've got shooting down it? And all of those complex challenges are things that we increasingly need to look at and deal with in new and different ways.
Okay, so I'm going to go completely off piece with my next question. You've stood up in front of a room of male, pale and stale middle-aged blokes. How does that work for you?
So I actually started my career out in manufacturing research.
Oh, okay.
So not something I'm
you're a big girl and you can look after yourself. I think that's what you're saying.
Yeah.
That's fine.
But certainly where I work in water, and I think in a lot of the more environmental engineering disciplines, we do have a really high proportion of women. So it's unusual for me now in my career to come into a room.
Yeah, and you're quite used to being listened to, so that's very good as well. Absolutely. No, I really appreciate your time, Anna. Thank you very much. And I'm sorry to sort of ambush you at lunchtime while we're here, but it's great and I appreciate it. Thank you.
No, great to talk to you. Thank you.
I'm now stood with Felix Merry from Natural Resources Wales. And Felix, you spoke practically really as the second part of a two-hander or joined presentations with Anna from Arup, who she talked about the SUDS directive, which for idiots like myself, I looked at them and thought, what is SUDS? Sustainable Drainage Systems. And you talked as a forest manager from a practical point of view to say, look, this is how we make it work. So, firstly, Felix, thanks for taking the time to talk to me.
Yeah, no, thank you very much.
Really appreciate it. But secondly, give us the elevator pitch of, Anna gave the theory, she gave the legal background, said this is what SUDS means, this is what is expected of people. How do you make it work in a forest when trees have been planted on marginal land in arguably wet conditions?
Yeah, so it's very difficult. So essentially, the legislation came in through the convoluted way that Anna explained it. I mean, it's not convoluted how Anna explained it, but we're at a position where in Wales we've got to deal with SUDS if the lead local flood authority wants us to. There's no real escaping it, and so we're currently the guinea pigs, as it were, and unfortunately this is probably coming for other areas. And what that's forced us to do is get better at the hydraulic modelling, get up to speed with hydraulic modelling, which perhaps we haven't really thought about since leaving university, and then making sure we can present the figures in the right way to get these schemes approved.
To justify your scheme. So you would have an existing access scheme, say for a harvesting operation, But because of SUDS, so because of the requirement of sustainable drainage systems, you have to justify what's going to happen when it rains, where it's going to go, how you're going to attenuate it, how you're going to manage it. And again, you took us through a sort of hierarchy, which was, in an ideal world, it wants to infiltrate in the soil rather than be collected. If it is collected, let's hold it, and the worst possible thing you can do is stick it into a watercourse, and possibly, is that right, into the drain? Is that the...
Yeah. So on that hierarchy, as it goes down, if we're unable to infiltrate, then we do have to direct it to a watercourse. So before it gets to the watercourse, we've got to have some way of keeping it back, attenuating, and controlling the rate that it is.
So swales, hydro breaks, in simple terms, timber dams.
Yeah, we steered away from hydro breaks just because of the upland forestry environment. It's not really suited to maintain.
Well, they need maintenance, don't they, as well?
Exactly. So we wanted sort of lower maintenance solutions, more simple and subtle. And so, we're essentially having to use a combination of swales and check dams, and we have to prove flow rates and run the figures, run the modelling figures.
Absolutely. And just to backpedal slightly, it's fair to say, SUDS as a concept and the implementing legislation came about in large part because of flooding and urban areas, and it is being applied, possibly, and I'll say this because I haven't got any skin in the game like yourself, it's being applied in areas it possibly wasn't intended for.
Yeah, exactly.
And I think because of that just provide a few headaches, and certainly given that there were a lot of Scottish delegates in the audience today, there were several people sort of, breathing huge sighs of relief and saying, thank goodness we're not in Wales. But it's coming.
It is. So in fact, not long after running it in Wales, the Welsh government put out a review sort of seeing how it had all run. And of course, myself representing Natural Resources Wales, also utility companies that have been affected by this, putting in power line routes and whatever, gas pipelines, housing developers obviously, but even farmers putting in new roads around fields. We felt that we were being unfairly impacted by this, but unfortunately, the way the legislation has been written and rolled out, we were pleading for a pass, and we didn't get that at all. We were just told
you were never consulted at the outset because it was presented as dealing with an urban issue.
Yeah.
And, my experience of legislation is that there's usually a consultation stage and draft legislation and reading, and that would have been the point to get in, but that boat's sailed, hasn't it?
Yeah, that boat sailed very early on. Yes, we did miss that. The powers that be missed it, and frustratingly, as Natural Resources Wales, we of course have an element of being on the SUDS approval board.
Yeah, so you can't play poacher and gamekeeper on this one, can you?
Exactly, it is very difficult.
You have to play the game.
Yeah,
don't
it
you?
is difficult.
So, I found it was a fascinating presentation. I enjoyed Anna setting the scene, and I really enjoyed you saying, well, all right, we can shrug and say maybe we shouldn't be here, but pragmatically, these are the ways that we are working with this and getting around it. And from the FEG Symposium point of view, it's exactly what the FEG Symposium should do, which is saying we're aware of these issues and this is what we're doing about them.
Yeah.
Thanks for your time today.
No,
we
great.
Appreciate it.
Thank you very much.
Thank you. For the listeners, we just shook hands then, and I'm going to say goodbye now. Thank you. I am now joined by Ewan Lloyd-Williams, who is a forestry consultant, and Ewan, you spoke today about CDM, the Construction Design Management Regulations, and how they apply to forestry. Hello, Ewan, firstly.
Now then, how are you doing, Andy? Yes, so the talk today was about CDM and how it relates to forestry. A bit like duck out of water, to be honest with you. A room full of engineers.
Yeah, but I, for my sins, have done quite a bit of work in construction with CDM and a bit with engineering, not particularly in forestry. And there's everyone knows the letters. We kind of know what they stand for, but not many people immerse themselves in what the implementation of the law. So the law came in because construction was hurting lots of people. And then people in forestry don't necessarily think that they're in construction. And that's the backstory.
And that is the backstory. I think, as I said in the presentation, as an industry, we've kind of buried our heads in the sand when it comes to CDM. Yes, we use excavators, we dig tracks. Yeah, there's big schemes as well. But the day-to-day forestry work, it is CDM. I think we've all realised it's CDM. But what I wanted to get out of today was, for everybody else in the room, and day-to-day forestry, harvesting, planting, that actually forestry is not a cowboy industry. We've
It's
got
professional.
Our own. It is, and we've got our own guidance. We're doing most of what's in CDM already.
Yeah.
Different terminology, different roles and responsibilities.
Yeah, but we're still identifying hazards and we're still managing risks.
Exactly.
And the reason the CDM regs came about was to formalise a set of existing legal requirements. So it was a new law, but it was just effectively grabbing things which were duties of care anyway and saying, this is what you need to do in what we define as construction.
And as a handbook for construction, this is what you need to do to comply with regulation.
I think it's also worth mentioning that, you're on the board of the Forestry Industry Safety Accord, like I am. You're involved in forestry safety management, for want of a better word. FISA have some guidance, don't they, which you've been involved in?
They do. So 12 months ago, FISA 808, which is the guidance for CDM in relation to forestry, and that was brought out as exactly that guidance for those of us, including myself, working in forestry, so we can relate to the CDM guidance, link it up to what we're doing day to day, and to make sure we're compliant.
And it's contextualised with some good examples of what within forestry is covered by CDM and some which maybe aren't as well, just to help with that clarification.
Yes, there's quite a number that aren't. One I didn't discuss today was fencing. And there's been a push by quite a number of people within the construction industry that fencing in forestry should be CDM. Well, you ask any farmer if he's going to have a CDM plan for his fencing next to a forest. I had the example of mounding, excavator mounding after a restock. Should that be CDM or not? It's an excavator. It's building a structure. It's breaking earth. But, common sense prevails and it's proportionate.
Yeah.
And that's where this document.
It doesn't mean you shouldn't have a risk assessment for that activity.
100%.
That's a trap, but it's not covered by these specific regulations.
Exactly. So I think it went down well today.
The objective today, as far as I could see sitting as a punter, was you were clarifying an aspect which people are aware of, and just giving that clarity and giving the opportunity for a bit of Q&A as well.
Little knowledge can be dangerous, and we've seen that over the years, especially on some harvesting sites, colleagues, other people around the industry.
Yeah.
They've been approached about CDM, where CDM isn't related to that kind of site. Someone with a little grasp of CDM applying that into a forestry context. This document's not just for us in forestry, it's for those who engage in forestry activity or engage people in forestry activity, and dare I say for the health and safety executive as well, just to set some clear boundaries and examples when it is, when it isn't, but most importantly, we need to be doing the risk assessment, identifying the risks, and people should be know what they're doing. And finally, communication. If people don't know what they should be doing and it's not communicated, that's when we fall short and that's when the accidents happen.
And we're not looking for a gap between a system and reality.
Exactly.
We're looking for a reality which matches a plan.
100%.
No, I quite agree with that. Really grateful for your time today, Ewan. Nice to catch up. Thank you very much.
Cheers, Andy.
I'm now joined by Chris Watson from the Forestry Commission, and Chris is a woodland resilience advisor, fellow Cumbrian. And Chris, you were speaking about resilience within the context of forestry management today. Do you want to give us just a quick resume of where we're at and where we need to go and maybe how we can get there?
Yeah, absolutely. To cut a really long story short, we know that we've got challenges with climate change, pest and disease, combination of those factors. And at the same time as that, we've never wanted more from our forests. We never wanted them to produce more for us, whether it be carbon sequestration or whether it be biodiversity immunity value, plus the obvious timber production. But that combination of challenges means that we've never had a harder time than we've got now for actually making sure that our forests are currently resilient, they're currently healthy, they're producing. But crucially, things are going to get even tougher in the future, and we need to start making decisions now and making plans now and adapting our forests now, so that in 30, 40, 50 years' time, as the climate really sort of starts to escalate, we start to see more storms, more droughts, more pest and disease, that we're as well adapted as we possibly can be for
and
the
this
future.
is in classic business terminology. It's business continuity management, isn't it?
Absolutely.
This is absolutely within your risk register in whatever business. It's just we're applying this philosophy to forestry.
Absolutely. The reality is this is happening. We want to be able to continue to do what we need to do. But unfortunately with forestry, we've got a sort of double whammy of it takes 30, 40, 50 years for our forests to change. We're starting to see issues now. They're only going to compound.
Yeah.
We need to make changes now.
Yet.
Exactly that. Yeah. We need to make changes now.
And I think what's interesting with this audience is you've got an audience with the Forestry Engineering Group of entirely engaged professionals who are actively engaged at various levels within forestry management, be it contracting, be it extraction, be it harvest management, be it planting. Everyone is keenly aware of the challenges, and equally are looking harder at the how. We kind of know the what, we know what's coming. We've done the why. It's how we deal with this.
Absolutely, yeah, and we've got some really sort of broad principles that we can start to apply to the forest to enable us to do that. We talk about species diversification. That's a big one, so that we're not putting all our eggs in one basket. That has implications for the sawmilling sector and for the tree nurseries. We need to think about the way we manage our trees and the way we thin them and harvest them, which has big impacts for the types of machinery we're going to need, the types of infrastructure we're going to need into the forest. We're going to need regular access into the forest. If we're going to deal with fires, we need fire breaks, we need clear zones, we need ponds, we need access. So there's all these factors are interrelated. We have a good idea of what we need to do. The challenge is that a lot of these things require cultural change and require, if I'm being blunt, to some degree, economic sacrifices. If we're going to plant other tree species that don't grow as fast as others, but they're going to be a better place to survive, that's a trade-off that we're going to have to
investment now.
It's an investment now.
It's the classic jam tomorrow that we need to do this and this is why. But it's got to be beyond the balance sheet, hasn't it?
Absolutely. It's taken a longer term. It's taken a long-term view of it. What's tricky is that in the past we've always worked on forestry investment and forestry planning in a relatively stable environment. So, bar for the odd storm or the odd outbreak, it's always been a fairly predictable environment.
Yeah, with a given number of years of a cycle of planting, thinning, harvesting,
absolutely.
So that you can see your pipeline, for whatever you want, timber line, but you can see your pipeline of production, and you can move resources accordingly, and things are changing, aren't they?
They are, and we're having to respond to things that weren't planned. We're already seeing that with pest and disease outbreaks, so our volume is coming from different places to where we planned it to come from, which means that when we come to thinking about restocking those areas, we need different species to what we're perhaps preparing for, but also we might be needing infrastructure and roads in places that weren't prepared harvesting because it wasn't due for another 10 years. So that's happening now. We've not even got there, and in the future, again, that flexibility is going to be something that we need to build in.
The situation is probably not going to go back to the stable situation 15, 20 years ago in terms of forestry management.
That business as usual that we think of as business as usual isn't business as usual anymore.
No.
Those days are gone, unfortunately.
And the new normal, to use that horrible COVID phrase, the new normal is going to be rolling and flexing and changing.
Absolutely.
And to get back to Darwin, it's not going to be the survival of the fittest, it's going to be the survival of the person who changes the fastest.
Absolutely, and is able to respond. But we've still got to take that long-term view, and we've got to start making those changes now. Yeah, absolutely.
Well, I think that's a fine note to end on. Chris Watson from Forestry Commission, thank you very much.
Thank you very much.
I'm now joined by Graham White from Forestry Land Scotland. You are you're not an agricultural engineer, but you're an engineer.
I'm a member of the Institution of Agricultural Engineers.
That's even better. Yep. So, Graham, you spoke today. It was a fascinating presentation. In 2 minutes, give us a really, really quick summary of what you were talking about and what the key themes were.
Well, it's all to do with forestry bridges and the problems that we've been having with them. Particularly steel and timber bridges that were built over the last 10, 20, 30 years. A number of them have been having deck failures, so holes through the deck have been appearing.
And these are timber decks, aren't they?
They are timber decks,
and there are certain correlations, you said, between, for instance, changes of product for treating timber. Do you want to just elaborate on that?
Yeah, that's right. Yeah, what we're finding is a lot of the modern timber treatments aren't lasting nearly as well as the older treatments. So Tanolithy is only giving us around 10 to 15 years worth of service, while as previous treatments gave us double that, really.
And presumably previous treatments were deeply carcinogenic and did all kinds of other things as well.
They had nasties.
There are legitimate societal reasons why we no longer bathe in creosote, for instance. But I think that's a very a valid point. So what have you moved on to? What's the answer?
Well, we decided we're looking for a more resilient solution, a more durable one. So that we've developed a process of, when we're removing the deck boards, the timber deck boards from our bridges, we've been putting precast panels down in their place. These have the advantage of being much more durable, harder wearing, and will hopefully give us like a really...
That was a heckler from the background.
Yeah, it will give us a much better design life. Something that will match the steel beams that they're sitting on, so that we will not have to revisit them again in 10, 20 years.
And concrete panels are a kind of proven this is a new application for a proven product, isn't it? So
It is.
We've got this, we can do this, we can do it with relatively basic construction techniques,
Yes.
which means it opens the field to have effectively non-specialists who can repair bridges as well.
Absolutely. What we're trying to do is it's all about getting the details right, so that this will go together quickly and easily on site, so that there's a minimum of work, and it's a process that we can repeat from bridge to bridge quite quickly.
And I guess it's a bit too early to talk about anticipated lifespans, but you'll have put some thought into that. But concrete does have quite a good lifespan, as the Romans can tell us.
Yeah, exactly. We were hoping for 50 years lifespan out of it. That's what we've designed it on. And it's all down to the wear and tear that they're going to get, and hopefully no abuse from machinery with tracks on, crossing, etc., which has been a bane of forestry engineers in the past.
Yeah. No, fascinating. Thanks for your time, Graham. Good to catch
No
you.
problem.
Thank you.
Good to see you too.
Bye-bye.
For more information, visit www.iagri.org.
I'm here this morning at the FEG Symposium, the Forestry Engineering Group Symposium at Gretna, just over the border in Scotland, and I am joined by one of today's speakers, who is Douglas Clark from Clark Engineering, William Clark and Sons Parkgate, to give the legal term. Douglas, thank you for joining me. I know it's a naughty question, but why are you speaking today? And be honest.
Okay, I'm being honest. I was roped into it. The company celebrated its 100th anniversary last year.
Yep.
Started by my grandfather, and we wrote a book on the company. And I sent a copy of the book to Jock McKee,
who's the chair of
chair
FEG, yep.
And so then I got roped in because he had read the book, and after 100 years. So that's why I'm here.
Yep. And just give us a little bit of background about the company and what you do.
Well, the company started as an agricultural engineer back in 1924. My grandfather was a blacksmith farrier. My father took the business in new directions. He made all the ploughs that raked and pillaged the Scottish hillsides to plant trees. And then that stopped around about the time that I joined the company, with Margaret Thatcher stopping the government having any money to buy land to plant trees. So we went into cutting trees down, and now the business does many, many things. And we've also left a trail of other businesses we've established and sold off. So, I mean, today the recycling side of the business is big. We're into railway infrastructure, making equipment for that. And still forestry and log handling is probably half the business.
Yeah, so a lot of the bread and butter is still forestry.
It's still forestry.
What do you think the challenges are facing the forestry business at the moment? You know, think about this as an engineer and think about the things you apply a bit of your time to.
The challenges to engineer, we are basically an engineering company. So we manufacture products when we see a need. So we're not really right up against the forestry problems, as you might say. We talk more to the contractors who are doing the work than we do to the people who are establishing or harvesting the actual, or making the decisions on the timber. We're dealing more with the contractors and meeting their needs. So there's always challenges, but it's an exciting challenge.
Yeah, and I think, you know, from a commercial advantage point of view, to get to those challenges early and come up with a solution is what keeps you in the game, isn't it? Just finally, thinking about people, what do you look for in people to work with or for engineers?
When we hire people, we always hire people first, skills second. So if we can get a skilled engineer who's a really good guy and has got a good fit in with our culture, that's utopia. But by and large, we always say, we'd rather have a really good guy who's got real enthusiasm and a good level of intelligence than Einstein with a bad attitude.
Yeah.
So if we've got a guy who's really well qualified but really doesn't want to be with us, he's the wrong guy. So we're always hiring people first, skills second.
Perfect. That's great. Well, look, we're sorry to drop on you at such short notice, Douglas, but really appreciate it.
Thank you.
You have been listening to Landwards, the podcast for the land-based engineering community, brought to you by the Institution of Agricultural Engineers.